Yeah, hello everyone. Welcome back to let's solve the last two problems of the AMC 12B 2021 fall test. Okay, so let's solve the problem 24. Okay, it's a geometry problem. I mean, I will basically I will provide some how I analyze and analyze all the geometry problems. Then I go to solve it. Okay. So let's see the triangle ABC has the side length of this. Okay. Basically, you can see the 11 square is this one is about 400, right? So it's 11 square is 121, right? And the 24 squares is somewhere about 625, 26 minus 50, right? And it will be 576. So you can see, okay, definitely this is the obtuse triangle, right? Okay, and the angle bisector BAC intersect this one and intersect the circumcircle. Okay, whenever we see the circumcircle, we always draw the circle first. Okay, then we have the AB and the BC and the CA. Okay, AB, BC is the longest, that's here, and AC. Okay, the ABC. So we know it's 11. We know this one is 20. And we know this one is 24, right? So the angle bisector BAC is here. Okay, it intersect here at D and also here at E. Okay, and if you know the intersect angle bisector, you know the arc BE must equal to the arc CE, right? So they span the same angle here. Okay. Oh, then we have the BDE, the circumcircle of BDE. The circumcircle of the BDE. Let's draw the circumcircle. Okay, so the circumcircle of the BDE and intersect the AB in the F. Okay, so something like this. Okay, so it asks us to solve the CF, right? Okay, let me think. Okay, the basic principle. Okay, if you can solve you can solve a geometry, right? So the geometry figure must be fixed, right? Must be fixed. Okay, so now we need to see how it can fixed, how what's the degree of the freedom that we can solve it. Okay, so if we have the ABC fixed, the circumcircle big omega is fixed, right? So the D is fixed and the E is fixed. So basically everything here is fixed, right? And let's see the other one. If this one BDE is fixed, so the circumcircle of this small little omega also fixed, right? So the F is fixed. So that's why if F is fixed, BF will be fixed and BC is fixed, and we know this angle, right? We can use the law of cosine, right, to solve the apply on the triangle the FBC to solve CF, right? Okay, so there, don't be afraid. Once you see it's already fixed, then definitely we can solve it, right? Okay. Now let's see how we can solve it. Okay, so we want the BF, right? And we have the AB. So did you see there is to the power point from the A to the theta omega, or to the circumcircle of BDE? Well, we have the AB times the AF equals, right? We have the AD times AE, right? So we know AD is fixed, AE is fixed, AB is known, so we can solve AF. Once we solve the AF, we can solve the BF. Once we solve the BF, we can solve the CF, right? So that's the how we analyze what's the step. Okay, what's the approach we want to approach it. Okay, So the first, we want to solve AE, right? How we solve AE? AE is a chord on the big omega, right? So we want to solve once we know the chord and we know if once we know the 2r, that's the diameter of the circumcircle of the omega, right? This is the diameter of omega. Okay, then we can solve AE based on the spanned angle, right? And the angle, this angle is alpha, right? And this angle is B. So we can, based on spanned angle, we can solve it, right? So this is simple. Let's solve the first, in order to solve alpha, right? Let's solve the cosine of the A, right? Because A is 2 alpha. It's equal to the AB square plus the AC square minus the BC square, then 2 times the AB times the AC, then you plug in the number, right? It's 11 square plus 20 square minus 24 square, and the 2 times 11 times 20, right? So here, when you calculate, okay, don't spend all of them, okay, using the square, the difference of the square, okay? So it will show you how we can do it. 11 square, that, and then here is a plus a negative 4, 20 minus 24 times 20 plus 24, 44. Very good, right? 2 times 11 times 20. So you can see 11 can be cancelled, right? So the final result is 1 over 8. Okay. You guys do your calculation. Okay. Then let's do the alpha. A is 2 alpha, right? So the cosine A is 2 of the cosine square alpha minus 1. And this one can tell us the cosine alpha is equal to the root 7 over 4. And we can get the sine alpha is 3 over 4, right? Okay, because we also want the alpha plus b, right? So we also want to solve the cosine b, right? Okay, cosine b is equal to the okay, is equal to the AB square plus the BC square minus the AC square 2 times AB then times BC. Okay, you guys, if you after calculation, you will see it's 9 over 16. Okay, so we can also have the sine B is equal to 5 root 7 over 16. Okay, now we can solve the 2r, right? 2r basically is the chord of the AC over of the sine B. Let's plug in the number is 20, then 5 root 7 over 16. Then this one is 64 over root 7. Okay, please don't do the rationalize here. Okay, all the middle step, you don't need to do the rationalize because this is not final answer. You might can cancel the square root of 7. Okay, we can see in the future. Okay, so this is our first step. Okay, let me highlight it. Okay, so AE, then the AE will be the 2r sine of the B plus alpha will be equal to 6 over root 7. Then we plug in directly, right? The sine RB plus beta is B plus alpha is sine B 5 root 7 over 16. Then cosine alpha is root 7 over 4. Did you see it? Yeah, plus the cosine b, that's the 9 over 16, and the sine alpha will be 3 over 4. Then this 64, 64 can cancel, right? So this answer is 62 over root 7. Okay, now first, we solved AE, right? That's the first step. Basically, we use the law of sine, right? Okay, now the second step. Okay, first step, second step. Second step, as what we analyzed before, we have the AE and AD, right? And so we have the, if we need to solve the AD, right? Because we want to use the power point. So that's why the second point is AD, right? In the AD, I want to apply the law of sine in triangle ABD, okay? So apply law of sine in triangle ABD. Okay, so what we can have is we have AD and the BD. Okay, so BD over sine alpha BD over sine alpha equals AD over sine B. So we can have AD is equal to BD sine alpha times sine B, right? So how do we solve the BD? BD is simple, right? Because we know from the angle bisector theorem, BD over DC is equal to AB over AC. Basically, the AB over AC, the total ratio is 31, right? So this part is 11 over 31 times the BC, right? So by angle bisector theorem, okay, by angle bisector theorem. Okay, so the BD is equal to 11 over 31 times AB is 11 over 31 times 24, right? Okay, so now and we apply all these numbers, right? We can get is 11 over 31 times 24. Then what is sine alpha? Sine alpha is 3 over 4. With sine B is 16.5 root 7. So now you can get AD, okay? So AD is 110 of root 7 over 31. Okay, now what's the next step? We already analyzed, right? Because we already have the AD and AE, we can solve the power point ABAF. We can solve AF, right? So we have the AB power point of the A versus theta omega. We have the AD times AE equals AB times AF. So now we can solve the AF, right? Equal AD times AE over AB. AB is 11, so we have the 11, right? And we can have the 110 root 7 over 31 times 62. See, that's why I don't want you to do the rationalize, right? So it's 20. Okay, good. Now the fourth step. Now you can see, right? We have the AF. So now we can do the BF equal AF minus AB equals 9. Okay, the final step, very simple, right? The fifth step is to solving the CF square using law of cosine, okay? We're using law of cosine on the BFC, okay? On triangle BFC, okay? Now we can solve it. So now we can solve the CF square is equal to the BF square plus BC square plus 2BF times BC cosine B. It will be 900, okay? Then the CF is 30, okay? Sure. Okay, let me get some background noise fixed first, okay? Yeah, thank you. I will solve the last question in the next video. Thank you, bye.